Hello student, in this lecture we discuss the phenomenon of hydrostatic paradox. Actually it is not phenomenon, it is a property. Okay, this is the third lecture in the topic mechanical properties of fluid. This is the new topic, okay, in the 12th syllabus. Okay, what is mean by hydrostatic paradox? Sir, I can show the three vessels, the vessel A, vessel B, vessel C. You notice carefully the shape of vessel A, B, C is different. Okay, and when you pour water in vessel A, then what happens? This water in vessel A move to vessel B and vessel C. Okay, in this way, when the pouring is stopped, then what happens after some time? You notice that in each vessel there is a height of liquid column is same. Okay, you can observe this in our daily life. Okay, and the height of liquid column is same. The water or the fluid is at rest. So you can say that the pressure at point A, the pressure at point B, and pressure at point C. All these A, B, C points are at same level in the same fluid. Okay, and you can say that the pressure at point A is equal to pressure at point B is equal to pressure at point C. How you can say that? Because the water is not flowing from vessel A to vessel B, and if there is a pressure difference, then water is flow from vessel A to vessel B. So this is the hydrostatic paradox. Okay, the pressure here in vessel A, at the bottom of vessel A, bottom of vessel B, and bottom of vessel C is independent on shape of vessel. Okay, on what factor it is depend? It is depend only on height of liquid column. Okay, suppose I will close here this, and now I will increase the fluid column in vessel B. Then you can say that the pressure at point B is maximum as compared to pressure at point A. But if the shape of vessel is different and fluid level is the same, then pressure is also same. This is called as hydrostatic paradox. It is very, very important because so many MCQs, theoretical MCQs are asked on this hydrostatic paradox. Okay, this is the statement. The pressure at any point inside a fluid at rest is dependent on height of fluid column and independent on shape of vessel. Okay, so the next point is Pascal's law. Pascal's law. Pascal made a law to observe the motion of a fluid. Okay, and he performed some experiments and created this law. That law is known as Pascal's law. Okay, in Pascal's law, it is very easy in our daily life. You can also observe that if suppose there is a balloon filled with air and you apply pressure at some point. Okay, and then you can observe that this pressure applied to any part of that air is equally transmitted. Okay, आपण पंपाने जेव्हा फुग्याला हवा मारतोय तेव्हा हवा मारत असताना आपण ऑब्झर्व करतोय की ते जे हवेचं प्रेशर आहे ते त्या फुग्याच्या सगळ्या वॉलवरती इक्वली क्रिएट होते. असं नाही की एका ठिकाणी प्रेशर जास्त एका ठिकाणी प्रेशर कमी. हे आपण डेली लाईफमध्ये ऑब्झर्व करू शकतोय. पास्कलने हीच गोष्ट ऑब्झर्व केलेली आहे आणि आपलं लॉ त्यानं तयार केलेलं आहे. फक्त पास्कल्स लॉ कुणासाठी ॲप्लिकेबल आहे? पास्कल्स लॉ इज ॲप्लिकेबल ओनली फॉर फ्लुइड विच इज ॲट रेस्ट अँड दॅट फ्लुइड इज एनक्लोज्ड. म्हणजे क्लोज्ड जी व्हेसल आहे, बरोबर, एखादं क्लोज्ड भांडं घेतलं की ज्याच्यामध्ये फ्लुइड इकडं तिकडं मूव्ह नाही होणार. तिथं तुम्ही कुठेही प्रेशर अप्लाय करा, ते प्रेशर इक्वली सगळीकडं ट्रान्समिट होणार आहे. फक्त ग्रॅव्हिटीचा इफेक्ट आपण इथं नेग्लेक्ट करायचं आहे. यू सी द स्टेटमेंट ऑफ पास्कल्स लॉ. द प्रेशर अप्लाइड टू एनी पार्ट ऑफ एन एनक्लोज्ड फ्लुइड. नोट केअरफुली, द फ्लुइड is enclosed, that is it cannot flow, also it is at rest, is equally transmitted undiminished. Undiminished mean in all direction. Okay, not only a particular direction. Okay, the pressure applied to any part of an enclosed fluid at rest is equally transmitted undiminished to every portion of fluid and also walls of the container, provided the gravity effect is neglected. Okay, in textbook this figure is given, and this is the experimental verification of Pascal's law. Okay, here in this figure you can observe that there is a triangular shaped vessel, and there are three pistons: piston 1, piston 2, piston 3, piston 4. Okay, you check carefully, the fluid is enclosed here. Okay, and the cross sectional areas of piston A, B, C and D is different. The cross sectional area of this piston is A, while this piston is double, this piston is triple area, and this piston is half the area. Now I will press this piston in downward direction by applying a force F. Okay, when I apply force, then I will create a pressure. That is, here I will create a pressure P is equal to F upon A. Then Pascal says that this is enclosed fluid, and if this fluid is enclosed, then this pressure is equally transmitted to every portion of the fluid. Here, if this pressure is P, then here also the pressure is P, here also the pressure is P, here also the pressure is P, here also the pressure is P. That is, this pressure is equally transmitted to all parts of the fluid and also walls of the container. Okay, now what happened? Here, these are the 2, 1, 2 and 3 pistons. Now when you press, you apply the force on the first piston, this 2, 3, 4 pistons are moving outward direction. Okay, 2 does not change the shape of the vessel. Okay, किंवा आपल्याला हे पिस्टन जे आहे ते त्यांच्या परत ओरिजिनल पोझिशनला आणायचं असेल, you apply the force in this direction here. Okay, for this piston you apply the force, here also the force and here also the force. You check carefully, this force is different. Okay, why different? Because here the cross sectional area is 2A, cross sectional area is 2A, and pressure required is P is equal to F upon A. Same pressure is here, P is equal to F upon A. If P is equal to F upon A, if area is doubled, the force is also doubled. Okay, जर काही ते एरिया डबल केला तर ऑब्वियसली फोर्स पण डबल येणार, म्हणजे 2F upon 2A, that is F upon A, that is P. Okay, therefore here you want to apply a force to F to move the piston to its original position. For this piston, the cross sectional area is 3A, therefore you apply much larger force 3F to this piston to move its original position. Here the cross sectional area is half, small, therefore you require less force to move the piston in its original position. Therefore the main fact of that Pascal is that the pressure applied to any part of fluid is equally transmitted. Okay, and this is mainly applicable in case of fluid, not in case of fluid, and in fluid it is applicable mostly for liquids and not for gases, because the gases are compressible and liquids are not compressible. Okay, in the next lecture we have to see the applications of Pascal's law. There are 2 applications, hydraulic press and hydraulic lift, and also some MCQs based on Pascal's law. Okay, thank you very much.